Hey everyone, today we'll be looking at the two-sum problem. In the problem we are given an array of integers num and an integer target, and we have to return the indices of the two numbers such that they add up to the target. We have to assume that there will be exactly one solution possible, so in our code we don't have to worry about the edge cases. And one more thing is mentioned that we can return the answer in any order. Let us go through the example one that is given. So we have an input array and the target is 9. In the brute force approach, we will have to compare each element with the rest of the elements in the array. So here we will compare 2 and we will check whether 7 plus 2 equals our target or not. Since at the start only we are able to find our target, so we can return the indices of both the positions, that is 0 and 1. Now let's take a look at the example 2. Here we are given an integer array of 3, 2 and 4 and our target is 6. So we will start from the beginning of the array. We will add 3 and 2. It is not equal to target, so we will add 3 and 4. That also does not equal to the target. Then we will move on to the next position, that is 2. We will compare 2 and 4 and it equals to the target, so we will be returning indices of both the locations, that is 1 and 2 as the answer. Let us go through one more example, and in this example our target is 18. So here we will first check whether 2 and 7 equals the target, then 2 and 11, and then 2 and 15. None of them matches the target, so we will move on to the next position in the array. Then we will check whether the sum of 7 and 11 equals to the target. It does, so we will return the indices of both the elements, that is 1 and 2. We looked at the brute force approach, and here we will compare each elements with the rest of the elements in the array. So if there are n elements in our array, then we will have to make n comparisons for each n element. So the total time complexity of this brute force approach will be big O of n square. In order to optimize our approach, we can reduce the calculations that are done by using a hash map. In the hash map, we will have a key value pair, where in the key we will put the element in the array, and for the value we will keep the index of that array. So let us go through the example first. First, we will check whether the target minus the current element exists in the hash map or not. So here 18 minus 2, 16 does not exist in the hash map. So here the value does not exist in the hash map, so we will insert 2 and 0 as a key value pair in the hash map. Then we will move on to the next element. We will calculate the difference, that is 18 minus 7, and the value is 11, which does not exist in the hash map. We will insert 7 and 1 in the hash map, and we will move on to the next element. 18 minus 11, that is 7, which does exist in the hash map. So we will be returning the current indices of 11, that is 2, and the value which we will get from the hash map, that is 1. So the return answer will be 1 and 2. Now let us take a look at the code in the Kotlin language. So here first we will be initializing our hash map, which will contain both key and value as integers. Then for each value in our loop, we will first calculate the difference, that is the target minus the current element in the array. Then we will check whether our hash map contains that value or not. If it contains, then we will be returning the current indices of our loop and the value which we get from the hash map. Otherwise, we will be inserting that value in the hash map. Let us go through the example with the code. So here we have an array and our target is 9. So we will first initialize our hash map, and then we will check whether the target minus our current element exists in the hash map or not. 7 does not exist, so we will insert 2 and 0, that is the value and the index position in the hash map. Then we will move on to the next element and we will check whether the 9 minus 7 exists or not. It does exist, so we will return the current position and the value which we get from the hash map, that is 0. And the total runtime complexity of this approach will be big O of n, since we'll be looping the array only one time. And the space complexity will also be big O of n, since we may be inserting the n elements in our hash map. That is it for today. Thank you and have a nice day.